well, what are we doing? We are creating create broadcast. All right. Okay. So it's a bit of a late night stream. I'm sorry, but half of my family is sick, and I just couldn't do it earlier. Now I realized I'm trying to do one thing. So I realized that one. So I'm trying to basically get. So I'm getting at. I'm getting at 52%, and this is with the current Terence style distillation. Um, let's see if I can pull it out here. Give me a second. This is the last one. Yes, and I've been using grog to distill these, so this is the last one. Now, what I want to do is the following. I want to pick. Um, let's grab one of the examples. I want to try the following thing. I want to try to maybe solve one myself. Equational theories project, mapping out the relations between different equational theories of magmas. Uh, I think space of equational theories of magmas, ordered by implication. So we shall focus only on the theories of a single equation, and specifically on the equational laws involving most four magma operations, up to symmetry and relabeling. There's a list in lean, he lists in plain text. Sorry, this is the project that I'm talking about. This is what they're doing. All right. And then we have, what do we have? Sorry guys, I'm just looking for these. Terence Tao's video gone. Okay. The reason is I want to try to solve one myself. I want to try to distill my mental, my thinking process about like how to solve one of these things. Um, See if that helps. In abstract algebra, magma finds a group point basic kind of algebra structure. I just would like to see one being. Okay, so some subdivisions of interest are listed here in the uniform here. Human readable blueprint examples include equation x equals x, x equals y, the singleton law, x something y equals y something x. All right. Here's a tour of self-selected equations, including the ones above. Automatically, equations explore, finite graffiti, contributing, building a project. And I think pattern style. All right, so I think a blog post by testing many of the above provers on sample implications of projects. Reasoning challenge. Okay, so there is some provers. Interesting. All right. I mean, maybe we could even ask the model to write some lean code. Itself, that's just fine on the pounder, so we don't need to bulk and all these other guys. For all x, y, x times x times y equals y times x. All right, yeah. Okay, I get it. I still would like to see. I still would like to see an example. I still would like to see grok. Equation reasoning challenge. Because this seems all related. Other tools. Rewrite rule inference. Kind of for equational theories. So what are equational theories? Okay, so this is part of these, right? It's inspired by these guys. Which distills information into a concise textual summary. Cheat sheet uses content for different times, experiments, and challenges. Yeah, it's all good. Cool. The raw implication graph. Example: x equals x times y implies that x equals x times x. X equals x times x implies that x equals x, implies that, yeah, yes, show proof. Okay, so these rewrite hypotheses. Oh, the rewrite hypotheses. The rewrite hypothesis. What? Okay, does not imply. What does it mean? Try this. It opens lean for web. Class magma. There's an operation, and then it says equation 3 for all x. X is an equation 375 for all x, y, x times y is the same as x times y. Yes, because we can substitute these, right? Theorem. What is that? Sorry. Equation implies also we're supposed to actually try this, as in like you're supposed to actually solve it in lean. Okay. So let's ask Grok a few things. What is math software called lean? It's some sort of theory prover, something like this, right? Proof assistant, okay, yeah. Formalizing mathematics, writing for verifiable proofs, building correct software. Teaching mathematics. Yes, the theory improving. Okay, so Lean is in the browser. All right, Lean's Lightning module. Do you know how to write? Do you know how to write Lean? I guess it does. So the whole thing here would be, how can we distill thinking about these, right? This law implies all of the single variable laws can hold on. Okay, so but still you need to figure out how to write this in Magma, right? But then maybe that's one thing that we can ask Grok to help us distill. It's sort of like, how do you think about proving this kind of stuff in Magma? You know what I mean? It's like, hey, this charge is based on these. So I have this task, this pilot task. Okay. Let's ask Grok. I got these tasks I'm working on. And I want you to help me distill what's the process of solving generally these type of task using Lean. Because maybe that actually helps the small model. You know, it's kind of like in both ways. It's like taking the Terrence distillation, combining them both. Right, and then providing. Is there any restriction in terms of the size of the cheat sheet that we can have? An average cost of no more than 1 cent and solve a problem in no more than 10 minutes. Okay. Copy paste these. Okay, so wait. What did it do actually? One simple question, does it access fine question project said do this one. Equation X implies equation Y. Anti-implication counterexample. You put this into a new file. What the question actually means. Equation X implies equation Y. You assume the law holds for all elements and all substitutions, and you cleverly plug in specific values to drive the target law. You assume that the law holds for all elements and all substitutions. Then you cleverly plug in specific values to derive the target law. No proof. Big chains of equalities by substituting variables in creative ways. Sometimes prove smaller helpful limits first. Build chains of equalities. Can I just pack everything? Can I just pack a selection of each of these? Can I just pack? Okay. It's false. Construct to find a magma. Typical template. You can use string magmas. Full workflow. Okay, maybe we can do something like this. Can you? So I'm trying to. Okay, so I am trying to build these into a prompt that I can use to trigger in context learning. I have these so far, although this is the one which v5. No, I want v4 actually. Which is the one that did these, that achieved these? I know v5. Okay, v5 did 52%. Okay, that's good. So v5 did 52%. Okay, so we'll do these. And so I'll just say, so this one I have so far. Can you enhance that so that we basically, after the model has decided true or false, it actually tries to build it in lean, either as a proof or a counter example. Give in the prompt a full-blown example, but also sort of the distilled process, the distilled metal model for working in lean. Still keep at the very end that, yeah, let's see what it does, because maybe this is an interesting idea. So basically we just take a distilled person's thinking process, then we take a tool distillation process, we kind of blend it together, we give that at the cheat sheet, that's in like think like Terence Tao, and then actually build it like verify like Terence Tao. See what it does. See if we get more than 52%. I'm curious. We're using the llama model, and I'll wrap it up here, okay? Because it's late, but at least I've tried something else. Give me the final prompt. I can just copy. I mean, this could be interesting. See if it actually works well. See if it actually works well. No, but I want, I like, oh, okay. I would like, so you are now, okay. Maybe that's it. Let's see how that goes, okay? So let's see how that goes. Let's put these, let's do a V6 with these. Let's see if that works. I actually made it faster, so now I can actually do um, it actually does 20 workers at once, and so it should actually be faster. Okay, V6. Let's go. Let's try. Let's try tab turns V6. Let's see. I mean, this should actually make it slow, but we can do 10 minutes. This is actually pretty crazy. Can we really do 10 minutes per problem? Like, this is a lot. We can actually, is there a restriction on the size of the cheat sheet? Oh, 10 kilobytes. Yeah, but 10 kilobytes is a lot, right? We're at 62%. Not bad. Let's see. This could be cool, actually. Pretty high. Not gonna lie. I'm not gonna fucking lie. This is actually really good. Let's see. Let's hope it stays high. It would be cool to get a 70%. This would be fucking awesome. Looks like we'll do. Ah, come on. Come on. No, no, no. Higher, higher. Do 60 at least, bro. Do 60 at least. Don't do these. That's barely better. Do 60. Do 60. Do 60. Come on, do 60. I have to read the prompt carefully. I can. I think 55. It's gonna do 55. It's gonna do 55. Oh, it's gonna do 55. Come on. 54. We've just done 54. Um, I think it picks another set of problems if I just change the seat, right? I think if I just do seat 10 and let's give it 100 problems. I just want to get a bit of a higher size and then see what happens. And then ask what's the prompt file size. How much more can we go? Oh, we're already at 8.5 kilobytes. That's pretty heavy, actually. Okay, we'll see. We will see. And I just want to see where does this one get. with 100 cases, and then I think we could. I mean, that's a very simple. That's the thing. Is a simple, right? Okay, we're still at 70. That's nice. Let's see how that goes with 100. I mean, 50 is still a relatively small sample. 100 could be cool. That's stupid. The fucking parsing errors are fucking stupid. Oh, come on. Because it's just a missed opportunity. All right, so I'm gonna close this one. This is before, and let's see if I can improve these. I basically want to use something like that. I just it's like instead of just making a cheat sheet of the equations, help the model get into the right headspace. That's the theory, right? 10 kilobyte. I don't know. Let's see. Maybe it'll get better. Okay, guys. And just check open router. What are the costs of these so far? Nothing, man. This is fucking awesome. This is very cheap. Management keys, credits, activity. Okay, with 100 is. Oh, wait a second. Come on, credits. Where do they have it? I forgot. View usage. There you go. I want to see the keys. API keys. There you go. Okay, 0.3. That's the usage that we've had. Activity of these. I just want to see these exactly. 38 cents is what we spent so far. So I'm gonna try to actually. Okay. So with 100, it's actually better. So we're almost at 60% really. 50 is a small. I'm gonna make a run with 1,000 now. I'm not gonna let's see what happens. Okay, so we're at 50. We're at 58. So these is, let me post about these. I'm just curious at the moment. Let's see. We're at 58. I'm gonna do a round of 1,000, see if that changes a lot. But I'm gonna wrap it up here, guys. Okay. So I'm gonna do a round with 1,000 entries. And I'm gonna wrap it up here, guys. See you tomorrow.